In this lesson, we'll cover polynomial division in two different ways. First, by using long division, and then second, by using something called synthetic division. Let's try this out in example 1, where I want to take this polynomial, x squared plus 6x plus 8, and divide it by this polynomial, x plus 2. Before we actually use long division to divide these polynomials, let's compare it to long division with whole numbers. It's good to look at this because the process is identical. All right, so let's say you wanted to divide, maybe 121 by 5. Like, how would you use long division to find the quotient and remainder here? The procedure is we take the 5, we set up this division, and we put 121 on the inside, and we ask for each place value, how many times can 5 go into a given number? So, well, 5 can't go into 1, so it goes in 0 times, but we don't write it. So we skip over to the next spot and say, well, how many times does 5 go into 12? And it can go in a total of 2 times. Because when you take 2 and multiply it to the 5, it gives you 10. That's the closest you can get without going over. Now, when you put this number here, you have to subtract it. So we have to add this subtraction in here. And when we take the difference, we get 2. And the next step is to bring down the 1. And we are at our last step. How many times does 5 go into 21? Well, it goes in a total of 4 times because 5 times 4 is 20. And we have this 1 here at the end. So what this tells us is if you divide 5 into 121, you get 24. That's your quotient. But you have 1 out of 5 left over. So you have this remainder of 1 out of 5 that you divided by. All right, so I want to mimic this procedure, but over here with these polynomials. Let's try it out. Well, step 1 is, okay, we set up this division mark here. So I'll set this thing up like this. On the outside, I'll put the x plus 2, and on the inside, I'll put x squared plus 6x plus 8. And our goal is to now try to cancel as much of this first term as possible by multiplying something to x plus 2. Okay, well, if you want to have an x squared, and over here you have an x plus 2, you have to first multiply this by x, because x times x gives us x squared. So what we'll do is, over the x's, I'll put an x here. So this is equivalent to putting a 2 here. Like we decided, the closest we can get to 12 is 10, and that's because we put a 2. This 2 multiplied to the 5, it gave us the 10. Over here, if we have an x and you want an x squared, you have to multiply by an x. So we now take this thing and multiply it to x plus 2. Now we have to be careful. If we take x and multiply it to x plus 2, we have to distribute it to both the x and the 2. First, you get x squared, and then you get x times 2, which is 2x. So at this point, it's like, okay, we just put the 10 here. Now we added in this subtraction. You have to subtract whatever you put here. So we have to do the same thing over here. We have to say, okay, well, we are subtracting that. But we gotta be careful because you're subtracting the whole thing. Like over here was just one number, but over here you want to subtract all of this stuff. So what I do is put the subtraction, and I set up some parentheses, and I go through term by term and subtract. So it's x squared minus x squared. That gives us 0, which I won't write. Then we have 6x minus 2x. And 6x minus 2x is 4x. I'll then bring down the 8, and we're actually at our last step. We now have to put something here so that when we multiply it to x plus 2, we cancel as much of this 4x as possible. Well, I know that has to be 4, because 4 times x gives me 4x. So I'll put a 4 here. I'll take this 4 and multiply it to both the x and the 2. When I do, I get 4x. I actually also get 8. And we want to subtract this thing. But for emphasis, I'll put some parentheses here to indicate that, okay, we're subtracting all of this stuff. We have 4x minus 4x, which is 0. And then we have 8 minus 8, which is actually also 0. And at this point, we've actually completed the process. This is the quotient, so let me mark that. This x plus 4 is the quotient. and there is a remainder. It just so happens that the remainder is 0. So you wouldn't say that there's no remainder. You would say that, well, there is a remainder, but the value of it equals 0. So what all this means is if you take x squared plus 6x plus 8 and you divide it by x plus 2, what you get is your quotient, which is x plus 4, but you have 0, your remainder, out of x plus 2 left over. So it's really equivalent to the thing that we have up here. It was our quotient, but we're adding on this 1/5 at the very end. So really you could just put your answer as x plus 4, but here I stated it so you can actually see the quotient, and so you can also see the remainder. So this is the process of polynomial division, or long division. It is analogous to what you do with whole numbers. So let's actually just maybe try it in a couple of other examples. So same question here in example 2. I want to use long division to divide 4x cubed plus 3x squared plus 2 by 2x minus 1, and we'll state the quotient and the remainder. So here I have a different notation, but it's just like the last example. It's this top thing divided by this bottom thing. The way you'd set this up is you'd put 2x minus 1, you would divide, and under here is where we put the 4x cubed plus 3x squared plus 2. Now one thing to note is I have a 4x cubed, a 3x squared, there's no x's, and then we have this plus 2 at the end. If it ever happens that you're missing something in between your highest and lowest x terms, you want to make sure you include it by using the following. You'll do 4x cubed plus 3x squared. There are no x's, but it might be nice to have a spot to refer to. So I'll just put in there are 0 x's. And at the very end, I'll put this plus 2. Okay, now that it's all set up, I'm going to go through the same procedure. My goal is to cancel this 4x cubed by multiplying something to 2x minus 1. Well, here I have an x, and here I have an x cubed. I have to multiply this by an x squared. So whatever I can come up with, I'll put it above the x squareds. But this time, I have a 4 here, and I also have a 2. So I know I have to multiply this by 2 as well to get 4. So just by reasoning that out, okay, I'm going to put a 2 and an x squared. And the reason is 2 times 2 is 4, and x squared times x is x cubed. So the next step is take this thing and distribute it to both terms of this. Okay, we do get 4x cubed. We get that first. But then when you multiply it to the -1, you get minus 2x squared. And we are subtracting. We have to subtract all this. And I'm going to put some parentheses for emphasis that we are subtracting both this and this. 4x cubed minus 4x cubed is 0. I won't write it. But next, we got to be careful. I have a minus. So this is 3x squared. Really, minus a minus is plus 2x squared. That's 3x squared plus 2x squared. That's a total of 5x squared. I'll now bring down the plus 0x. And I want to keep going until I get to my last spot. So now what I do is I ask myself, okay, what do I multiply a 2x by if I want to get a 5x squared? If you focus on the x's first, I know an x times an x gives me an x squared. So the variable has got to be x. But what do you multiply 2 by if you want to end up with 5? I think we're going to have to use a fraction here. So I think I'll put plus 5 halves. 5 halves because 5 halves times 2, the 2 will cancel with the 2 in the denominator, leaving us with the 5. So it's weird that it's a fraction, but it is the right answer. All right, let's do it. 5 halves x times 2x is 5x squared, so that's good. But then 5 halves x times -1 is -5 halves x. And I'm doing this so I can subtract this away. But I want to make sure that I subtract it from both terms, this one and this one. 5x squared minus 5x squared is 0. That's good. Now 0x minus a minus is plus, so it's going to be 0x plus 5 halves x. So we actually get 5 halves x. I then bring down the 2, and we're actually at our last step, where I have to put something here so that when I multiply it to this 2x, I cancel this 5/2 x. Well, I know it has to be a fraction, and I have to have a 5 in the numerator, so I have a 5 left over down here. But there's a 2 here, but I want a 2 left over in the denominator. I think it's going to be 5/4. 5/4 times 2, we'll put a 2 up here, and a 2 and a 4 cancel to leave you with 2 in the denominator. There's already an x, so I don't want another x here. It'll just be a number, and that number is 5/4. 5/4 times 2 is 5/2, times x is 5/2 x. Okay, and lastly, 5/4 times -1 is -5/4. When I subtract this, make sure I subtract both pieces, 5/2 x minus 5/2 x is 0. Then we have 2 that's really plus 2 plus 5/4. So maybe just to put that over here. If you're doing 2 plus 5/4, that's really, okay, that's 8/4 plus 5/4, which is 13/4. Okay, so when I take 2 and I add it to 5/4, I get 13/4, and that thing is my remainder. So in terms of the quotient and the remainder, I'll put that up here with my answer. The quotient was 2x squared plus 5/2 x plus 5/4, and I have a remainder of 13/4 over 2x minus 1. So a strange answer, but this thing here is the quotient, and this thing here is the remainder. Okay, we just did 2 examples using long division. I'd like to try this other method called synthetic division. And really, it's just a shortened version of long division. Essentially, what we're going to do is just not write any of the x's down in the process. It's worth noting that it can only be used when you're dividing by something like x plus a number, like x plus 5, or minus if a happens to be negative. So it kind of starts the same way where, all right, we're going to set up this division symbol here, like this. But outside here, we don't put x plus 5. Instead, you use the number that makes this equal 0. So it's x plus 5. -5 makes this 0, and that's what we're going to put on the outside, -5. Okay, here, last time we wrote the entire polynomial, including the x's. What we're going to do now is just not write the x's, and just in order put down the coefficients, 4, 7, and -21, just like this. 4, 7, -21. If one of the terms happened to be missing, we would just put a 0 here as its coefficient. Okay, here's where it looks a little bit different. We now just write a line down here like this. And the first thing you do is simply take this 4 and write it here. Just bring it down. The first number always just comes down. Okay, now what you do is you take this number, you multiply it to the -5, that's -20, and you put that number here. You then add these two things together, 7 plus -20. That is -13. And then you repeat the process, where you take this number, multiply it to this one, place that value here, and add those two numbers together. And you repeat that process until you get to this last step. So we have -5 times -13, and that is equal to 65. And then we take -21, and we add that to 65, and we get 44. And the process is over. But like, where's the answer? What's the quotient? What's the remainder? I'm going to add some things in here in red that technically don't go in the answer, but I'm just kind of showing you how it lines up. This was a 4x squared, this was a 7x, and the -21 was a constant. Well, if this is the x squared term, this drops down to the x term. If this is the x term, this drops down to the constant term, which is just going to be 13. And then this number over here is the remainder. So in terms of the answer is 4x minus 13. So it's these two things that make up the quotient. And then over here, the 44 is the remainder. So over here in my answer, I'll say, well, the remainder was 44 out of x plus 5. So this process is a lot faster because you're not writing down all of the x's, and it's a very quick procedure. But that's it, the quotient and the remainder. In our last example, we're going to use synthetic division to answer a slightly different question. We're going to use the remainder theorem, this thing, to find the value of f of 1, where f is this polynomial. The remainder theorem says that if you divide a polynomial by something of the form x minus a, where a is a number, then the remainder you get is equal to f of a. So over here, a is equal to 1. And we're going to divide the polynomial by x minus a, which is x minus 1. The remainder that we get will be equal to f of 1. So how does this work if we're using synthetic division? Well, let's see. I'll first set up the division. Since we have x minus 1, the number that goes here is going to be positive 1, the number that makes this thing equal to 0. And then inside here, I'm going to list the coefficients in this order. And we're not missing any of the x's, so I don't have to include a 0. So that is 3, -8, 7, and -6. I'll draw a line down here, and we'll begin the process. I first bring down the 3, so I just copy it down. I take this 3 multiplied to this 1. I get 3, and I place that number here. I now add these two numbers together, and I get -5. And I repeat this process until I get to the very end here. -5 times 1 is -5. 7 plus -5 is 2. 2 times 1 is 2. And -6 plus 2 is -4. Here's my quotient from these first three terms, 3x squared minus 5x plus 2. But all I care about here is this thing, the remainder. The remainder is equal to -4. And according to the remainder theorem, that's going to be equal to f of a, which is, in this case, f of 1. So that's the answer for this problem, that f of 1 is equal to -4.